We are in the home stretch, starting off on 73, and this is looking at solution chemistry. And this set of problems here we're looking at doing dilutions. For this first one, we have a stock solution of 14.8 molarity ammonia. And how many milliliters of this solution do you dilute to make 1,000 milliliters or a liter of a 0.250 molarity solution? The way we would go about looking at this particular problem is we could make this more complicated, but I'd rather not. We're going to do something called MV, molarity, volume, molarity, volume. And it's just based on its solution. So all you have to do is pair these guys up together. So for example, you have a stock solution. Doesn't matter which pairing goes where. I'm going to call this molarity 1. How many milliliters volume of this stock solution? That sounds like a volume to me, and it also sounds like a question. So I don't know that. Would you make the dilute 1,000 milliliters? That's another volume, a new volume, in a new concentration. So just plugging in numbers into this formula, and we're home free. Here we go. 14.8 molarity times some volume, who knows, is equal to a new concentration. And as long as the units are the same, you don't have to make any changes. And I need a volume in this case. So based on my unknowns, my answer, volume, is going to come out in milliliters. So I don't have a choice. It's going to come out that way. If I solve for my unknown, isolate the variable, slide this underneath over here, my volume will become 16.9 milliliters of the stock solution that I would dilute up to this volume. And when I do so, that'll be the concentration of that solution. Easy enough. Let's do this again. If you take a 10 milliliter portion of the stock solution that we had in the previous problem, so again, I'm going to call this one volume 1, and dilute it to a total volume of 500, so a new volume, what will be the concentration of the final solution? Final solution, concentration. I don't know, but it is 2. So we'll set it up again, just like we did in the previous problem. 14.8 molarity. And the volume of it is 10 milliliters. We're going to take 10 milliliters of it. And we're going to figure out what this new molarity is going to be. And the volume in this particular example is a dilution up to 500 milliliters. Okay, if we solve for the molarity, isolate that, swing 500 mils underneath over there, you will find an answer of, drum roll please, 0.296 molarity. And just for fun, it happens to be ammonia. Okay, let's look at 75. 75? Yeah, 75. Sheet over here. For this problem, starting with a solid sucrose solution, describe how you would prepare this concentration, that concentration, this volume. Okay, well, starting off with a solid amount, we'll go through the math process and then we can talk at the end. So I have a volume, I have a concentration, and I have solid, so as much as I need, and I need to dilute it to that volume to provide that concentration. We'll get there. Having these two units, this is a volume, this is a moles per liter, I can combine these to get moles. And we'll see what happens when I get with moles. So I'm going to take this volume, and that happens to be 0.250 liters, and I'm going to multiply it times the concentration. It happens to be the same number. moles per liter. And if I do that, I end up with an answer of 0.0625 moles. And this is sucrose. Okay, I want to figure out what mass I need, because I have moles here. I'm trying to make this substance, but I can't go somewhere and grab moles of sucrose. I can get grams though. Therefore, if I take these moles and figure out what the molar mass of sucrose is, I can measure out some grams, put it in this volume of solution, and get a concentration. That's exactly how to work. So the molar mass of sucrose, we talked about this before, happens to be 342 grams per mole. If I do this little calculation, I get 21.4 grams of sucrose for a final answer. Okay, now that I have that, describe how you would prepare 350 mils of that concentration, starting with, this is just like the problems we were doing. So these two guys match up. This is a volume, this is a molarity. And looking at the other problem, I have a volume, how I would prepare of that concentration. Molarity. So one of these, describe how you prepare this of this. So somewhere in here, it seems like I have more information than I need, right? Describe how you prepare this of that concentration, starting with a whole bunch of this. So here it's a little bit confusing. It's like, well, hold on a second. I thought I need a variable in here. And you do have some variable. So we have to think about, okay, what am I missing? I got a whole bunch of stock solution here. But I really only want this concentration. So how much of this do I actually need? I don't need it all. I need some amount of it. So this is actually the question. How much of it do I need of this concentration to give me this volume of that concentration? So as I mentioned before, it doesn't necessarily matter who you pair up with who, as long as they go together. So I'm going to go ahead and just put these guys here because they are first. The molarity is going to be 0.100 molarity times the volume, 350 milliliters, is equal to the concentration of this stock solution and how much of it do I need. And again, I got a whole bunch of it. I'm not going to use it all. How much of it do I need? So I want to solve for that. Isolate, bring this over underneath the bottom, and our answer will be, I only need 23 milliliters of it if I do the math. There we go, problem done. All right, this last one is going to run me over my 10 limit mark, but I'll be good. We'll get done before 15 minutes. Look at this problem. We have an 8.65 gram sample of some metal hydroxide. We don't know which. It's one of these guys. It's dissolved in 85 mils of water. An acid-base indicator is added and the resulting solution is titrated with a concentration of an acid solution. An indicator changes color, signifying an equivalence point. We will have talked about that in class after we reach an equivalence of this amount of HCl. What is the molar mass of the metal hydroxide? So the first thing we should probably do in this problem is create an equation so we can understand how these things relate to each other. And reading through here, we can see that it is a metal hydroxide. It's a +2 for all three of them. And we're titrating it with HCl. And we know that our products are going to be a metal chloride. It was metal +2, so that 2 comes down, chloride is 1. Oops. Let's kind of do that. And the other substance we're going to get out of this is going to be water. It's a neutralization. Now, if I go ahead and go through the balance on here, I'm not going to waste a lot of time going through. It happens to be 2 and 2. All right. Now, what I think is a good tool, and you should use this as well, is to kind of just like organize information and figure out what you have of what. So for example, I have a mass of this stuff, metal hydroxide. So it's 8.65 grams of it. Okay, it's dissolved in a certain amount of water. Yeah, that's not that important because water doesn't affect anything other than the concentration. The concentration of the acid, I think that's important. 2.50 molarity. Indicator changes color after this much has been added. So these are two very important pieces of information together because it gets me to moles. What is the molar mass? So what the question here is the grams per the moles, molar mass. So if you have this in front of you, I think this is really telling you exactly how to do the problem right now. I have volume, which is really, I want liters here. Liters times moles per liter gets me to moles. These guys relate to each other, moles to moles. If I have moles of this and I have grams of this, grams per mole, molar mass. So that's going to be our route to get this problem done. Okay, let's go ahead and fire through this and see what happens. I will take my volume, but very, very important, I have to change that over to liters. Must be in liters because I'm multiplying it by 2.5 moles per liter. And after I've done that, I have an answer of 0.14225 moles. And this is HCl. Your next step is to take those moles of HCl, compare it to the moles of metal hydroxide. What are the numbers that are in front of each? It is a 1 to 2 relationship. Having that information, I can find that the answer should come out to be 0.07113 moles of the metal hydroxide. Now that I have moles of metal hydroxide and grams of metal hydroxide, I can take those 8.65 grams and divide it by the moles and get an answer of 121.6 grams per mole. All right, so the last part here is figure out what the identity of the metal hydroxide is. To do this, for this total number of moles, grams per mole, I want to subtract off the hydroxide, and the hydroxide is 16 plus 1, but I have 2 of them. So 17 times 2 is 34. So I'm going to say minus 2 times 17. That gives me an answer of 87.6 grams remaining for the unknown metal. And if I compare it to these 3 metals here, the one that fits perfectly for that is strontium. And that is our answer. And we are done with chapter 4.